All right, let's talk about 4.5 logarithmic properties. First, we start with some rules. So first we have the product rule for logarithms, and the product rule for logarithms says that for m and n in the real numbers, and these can even be algebraic expressions, and your base being greater than 0, then your product rule for logarithms states that if you take the log and in your input your two things are being multiplied, you can break them apart over addition. That is, you add together their logs separately. The quotient rule says the exact same thing, except if it's a division on the input, it's a subtraction on the output. And then the power rule says that if you raise a number to another number inside of your log, and again, these can either one be algebraic expressions, you just take your power, you can just bring your power out front as a multiplication. And so you can think of this as sort of stepping down in a way. If addition and subtraction are the most basic, and then another tier above that you have your multiplication and division, and another tier above that you have exponentation, well, here you see multiplication getting turned into an addition, so that steps down a tier. You see division being turned into subtraction, so that gets turned down a tier. And then you see exponentation, which is just repeated multiplication, being turned into just a single multiplication. And that is exactly how logarithms work. And it's these properties that make this so supremely, just ignorantly useful in the future. And we say that these are the rules for logarithms instead of saying the product rule just by itself, because the product rule, the quotient rule, and the power rule all show up in derivatives in the future. So pause the video for a moment and get all of this down, write this stuff down, and the main thing that you need to write down is just assume that everything works, but it's really just these pieces are the really only three things that you need to write down. And if you can get those three things down, we're going to use them just repeatedly. We're going to use them both to expand, which is going from the left side to the right side, and we'll also be using them to condense, which is going from the right side back to the left side. So we can make these things very compact, or we can break them apart into multiple parts. But first, we'll look at some examples. So let's talk about condensing and expanding logarithms, and let's start with condensing. So say that you're given the logarithm 4 times log a plus log k. Well, first, notice that there's no base on these. If there's no base on these, it means log base 10. We have a base 10 number system, as in there are 10 unique numbers that we work with, the numbers 0 through 9, that's 10. And so when we say, keep this in mind, this is worth jotting down somewhere, that when we say the log of x, what we actually mean is the log base 10 of x, because that's just how we normally write. So if you see log, you mean log base 10. In our case, sometimes if you're working in real high mathematics, log of x means the same thing as the natural log of x because you just work with it so much. So it depends on the context. You see log base 10 a lot more in engineering type applications or in data, computer science type applications, and you see the natural logs show up a lot more in pure math. So it just depends on your application, but it's always pretty clear what it is you're talking about. But what we want to do is use those three properties to condense this, which means write it as a single log. Condense means write as a single log. So we're going to go ahead and write this out first. So this is 4 times the log of a plus the log of k. And we're going to notice that the first thing we want to take care of when we're condensing is the multiplications. So we can use that third property that says, well, the log of a something to another power, we can just write that out front. Well, that's what we've done here. We can just write this, and we're just going to move this on down. So we're going to say this equals, well, this is just the log of a to the fourth. We just used that property that said that the log of m to the n is n log m. It's the exact same thing. So we just used it this way, is all that we did. We had 4 times the log of a, so the 4 was out front, so now the 4 goes in here as a power, and we're just using that third power there. And then we're going to write plus the log of k. And then we're going to use our first property that says that if you added together two of these things, that's the same thing as just multiplying them inside a single log. So we're going to say that this is the log of a to the fourth times k. inside parentheses so that it all goes together like that. And that's it. If I had given you this problem down here and said expand log of a to the fourth times k, the answer would have been this up here. Just the same thing in reverse. So expanding is the opposite of condensing. So that is how to do it. You just use those three properties and move this stuff around. So I invite you then to go ahead and look at this second example here. It says condense the logarithm c log a minus y log b. See if you can write that as a single log. It's base 10 again because it doesn't say so. So go ahead and see if you can't pause the video and give that a work. You should be able to get it all as one logarithm. I'll give you a hint. It's definitely going to have a division in it somewhere because there's a minus here. So give the video a pause and give this a shot. All right, so let's take a look at this. So we're going to start with writing the problem as usual. So c times the log of a minus y times the log of b, like this. And so we usually want to deal, if we're condensing, we want to deal with the exponents first. So these are multiplications in front here, so we're going to tuck each one of these in as a power. That's that third property that we're allowed to use. So we say that this equals the log of a to the c, the minus stays put, and the log of b to the y. So we can just tuck these back up in here like this as powers. That's that third property. That's how that works. And now, when you subtract a log from another log, the way that that works is you can rewrite that as a single logarithm with the thing that was first on top, whatever it is, divided by the thing that was second. That's that second property that we're using. And that's it. You're done. I know that I've condensed this because at the end of the day, I've got one logarithm written, so it's condensed. And that's literally all that there is to condensing these things. It's just using those properties, except read from right to left, to work on these. And the best way you can get good at these, as usual, is just working a whole bunch of them. So we've got that. So let's go ahead and scroll on down and look at how to do some more of these. So here's one of these that asks you to do the opposite of condensing, which is expand fully the log of the cube root of x to the fourth times z to the second over y to the fourth. So we give this to you as one log, and we want it as a whole bunch of them. And this is just practice using these properties is all that it is. The ability to actually do this isn't terribly useful in mathematics. It's just you do run across this as steps in much larger problems where the answer to that problem is actually useful. So this is like just some practice for your sub-step sort of thing. But as usual, we're going to go ahead and write this here. So it's the log of the third root of x to the fourth times z squared over y to the fourth. And you can work these about however you want to. My deal is usually to come in here and try and write these things. First off, get rid of the square roots is the first thing that I would do. I would write this as a fractional power. That's going to make this an awful lot easier to deal with. So this is the log of, it's still going to be over y to the fourth. It's still going to be times z squared. But the cube root of x to the fourth is x, okay, to the fourth still, except that 4 is on 3. That is, it's being divided by 3. The cube root of x to the fourth is the same thing as x to the fourth third. So now that we've got that out of the way, this is going to be a lot easier to deal with. So the way that I like to think of this is, you deal with exponentation when you're condensing, you deal with that first. You do it in the order that you wrote it down, 3, then 2's and 1's. 2's and 1's go together, however you want to deal with it. With this, you're going to want to deal with your property 1 and 2. Again, look at your notes. Deal with those first, then deal with your exponents last, is usually the way that you're going to need to do this in terms of order of operations if you want any kind of sanity in doing this. So the biggest operation in here that I see is this giant division. So let's go ahead and write that. So we're going to write this as a giant division. So a giant division breaks apart as the log of everything on top, so x to the 4 thirds times z squared, okay, minus, because it's a giant division, the log to the same base. And again, if this were log base 7, then there would be 7's. If this were log base 7, then there would just be 7's all over this thing, like this. But it's not. It's log base 10, so we get to ignore that. Times minus the log of whatever is there on the bottom. Cool. So we're step by step going down through here. So we're going to come on over here and finish this problem out. So there is some stuff that we can expand on this second deal here. And back here on this first deal, you see that these two things are being multiplied by each other. So that's going to be an addition. So let's write these as additions. And I'm not going to do anything with exponents yet. I'm just going to get this out. If you want to go ahead and deal with exponents on parts of these at a time, if you want to, go ahead. You're welcome to, but I'm not going to bother with it. So log of y to the fourth is the last thing that we're looking at. And now on each one of these, all that I'm going to do is just take my exponent, and I'm going to use that third property and bring it out front. I'm going to take my exponent, and I'm going to bring it out front. I'm going to take my exponent, and I'm going to bring it out front. And that is going to end with me doing this. It's going to end with me doing 4/3 times the log of x plus 2 times the log of z minus 4 times the log of y. And that's it. You want to come back in here and put in parentheses? You're welcome to. But if it's just a single argument, that is, there's only one thing inside the log, you don't need them. So I would leave it like this. But that's just me. And that's fully expanded. There's no other properties you can use. There's nothing else happening on the logarithm here for you to do this with to begin with. So you're done with this problem. That's it. It's finished. That's it. So go ahead and get this down, and we'll move on to another one. So let's do this last one here. And it says to expand fully the log of x cubed y to the second over z to the fourth. And this one's even easier than the last one. So again, we're just going to write it out first. And I invite you, by all means, please pause the video, give it a shot yourself, see if you can get the answer right. If you can, awesome, then you understand this. If you can't, you need some more practice, and that's fine. It's just using those three properties over and over. So the biggest thing that I see here is that big division, so we're going to deal with that first. So it's the log of x cubed y to the second. Make sure to put it in parentheses because it's more than one thing. Minus, because a division is turned into a subtraction. That's your second property. The log of z to the fourth. And I'm going to put it in parentheses just so I don't lose track of anything. Okay. Now, this first thing is going to be able to be broken apart into a couple different parts. So this is a multiplication. So this can be written as the log of x cubed plus the log of y squared minus the log of z to the fourth. Okay. And I'll go put parentheses back around all these two. And we can look at this very simply now as each part, you just bring the exponent out front as a multiplication. 3 log, that's using the third property. 3 log x plus log 2 log y minus 4 log z. That's it, you're done. That's the whole thing. You're just using those three properties over and over and over and over and over. And you can use them either tucking things back in or pulling things out. So there's another version of this problem I could give you that said condense, and then I give you this bit at the end, and the answer would be what you were originally given. So you should be able to do these in either direction, up to you, but you should be able to see how those properties work. So you're either tucking multiplications in, or you're bringing multiplications out, depending on whether you're expanding or condensing to begin with. But let me get that out of the way for you there. Look at this, see what you can learn, give these things some practice, because you never know what you're capable of until you do it yourself. So I wish you luck, and I'll see you in the next one, which is, by the way, the last one for the first part of pre-calculus.